Hi, everyone. All right, welcome to the Rise of the Agent. We're going to be talking about agents today, specifically in Rails. I'm Kinsey. It's nice to meet you all. I'm from Denver, Colorado. I am on the coding agent core team at GitHub. I'm also the VP of the board of directors at Ruby Central, and I'm also a mom. My two kids are here today for watching me talk for the first time. So if you see them, say hi. Thank you. Yeah, a little bit more about Ruby Central. We're behind Ruby Gems and many open source initiatives. Marty just gave a lightning talk. He's our head of open source about CRA, which was great. And we also put on RubyConf. We're about to announce where that is in the US and when. We would love to see you there. And also behind EXO Ruby, that Jim is doing small local conferences across the US. So be sure to check those out too if you're in the US. So today, we're going to talk about what agents are, how to build them, best practices when building them, the future of agents, and ethical considerations when building agents as well. So when I first thought about AI and Copilot at GitHub, I was on a different team. I was on the deploys team at GitHub. I thought I was going to be tuning LLMs. I wasn't really sure what I was getting myself into. And when I joined the agent team, it was a lot different than what I was expecting. I was not tuning LLMs. That's someone else. But agentic AI is really the new frontier. It's where tooling and AI companies are headed. But what are agents? What is agentic AI? What are workflows? Before we go any further, we're going to do a little bit of a vocab lesson, so we're all on the same page. Agentic AI at a high level is, oops, sorry, I went too far. There we go. Agentic AI, this is high level, the notion that AI has agency, right? It's able to act without being prompted. It makes steps to achieve a goal, and it acts in a more human-like way. Agents specifically are the software systems behind this. They can act autonomously, they can make decisions, they can understand context, and they can chain tasks without being hard-coded to do so. So a modern agent typically has a goal or objective, tools, a planner or orchestrator, and long-term, short-term memory. But we'll get into those building blocks more once we chat about how to build these agents. So what are workflows? We hear this term a lot too, and a lot of times workflows get confused with agents. They're a key concept in agents, but they're not the same thing. They are similar, and workflows can be a part of an agent. This is why agents just aren't chatbots, and it really turns them into structured and more reliable processes. So this is a quick chart of what the difference is between a workflow and an agent. A workflow isn't as good at learning or being flexible where an agent is. Workflows are very regimented and rule-based, whereas agents are model-based. So workflows are really good when you know exactly what steps you need to take, and agents are better at adapting and problem-solving open-ended problems. So here's a high-level overview of what a workflow could look like. So you can see we're just chaining LLM calls here. Versus an agent, you can really see that it's a circular action here, human input, that sort of thing, action feedback loop. But we'll get more into this later. Just wanted to show you kind of a high level the difference. So workflows plus agents really make up agentic systems, which is another term that you may have heard. So I could talk about workflows all day too. There are best practices for those, but we only have 30 minutes. So we're going to focus on agents for open-ended problems where it's really hard to predict the number of steps that you're going to take. And, there's going to be a lot of turns, you have to have some level of trust in these agents because they have a lot of autonomy. But they're really ideal for scaling tasks in trusted environments. So, because they're autonomous, higher costs, right? Potential for compounding errors. So extensive testing in sandbox environments is essential. But again, we'll get into that more when we talk about best practices. But agents are honestly really, really exciting. There really is a big paradigm shift from imperative programming, where we tell software exactly what to do, to declarative goal setting, where we define objectives. And there are different types of agents, which you may have heard of. There are learning agents, and they kind of improve over time, learning from experiences, learning from what you put in, learning from tools, and adapting their behavior. We also have utility-based, which improve their performance over time as well, and more And then we also have model-based, which are using, I'm sorry, I'm behind on my slides. So utility-based optimize actions based on a goal where we use trade-offs to maximize overall happiness or performance. Now we have model-based. We maintain an internal model of the world to inform decisions beyond just the immediate inputs that we're getting. Goal-based, which is where we set a defined goal and work towards those. And then we also have simple reflex, where we're just getting the information as we go, X, Y, doesn't rely on memory or anything like that. So we have a lot of different use cases of how we use these agents in the real world. The first one is customer support, right? These make a really good use case for agents. Same with security threat detection. Travel concierge is another good real-world application for an agent. And then, of course, coding agents. Coding agents can really take a mundane task and really do awesome things for you. It can create a PR for you, and I want to show you briefly what we've been working on at GitHub on our coding agent team.
Incredible! I like it! I'm unstoppable! I love it! It's undeniable! I see it, I want it, I get it.
Okay, I promise that says like, yay, GitHub as I'm gonna get, but I just want to show you really quick. Basically, you assign Copilot to a PR or to an issue, and it creates a PR for you, and you review it. And you can also see the difference here of the agent actually writing the code versus you just kind of prompting Copilot like, hey, how do I do this? So really taking that next step forward. But now we're gonna talk about building agents, get into the meat of the talk. You can do a bunch of different things with it, right? So you can do single or multi-agent. Today, we're only gonna focus on building a single agent, not multi. And here are the kind of essential building blocks or common building blocks that we have when building agents. And we're gonna dive into kind of each of these pieces to really solidify these concepts. I built in a Rails application like a little dummy support bot, or support agent. I shouldn't say bot, it's more than that. It's a support agent, and the example is all in Rails. So we'll dive into those and each of these examples. So we have the tooling layer. For this, I definitely recommend using MCP. I'm not sure if you've heard of it, but it stands for Model Context Protocol. It's a standard that defines how AI models securely discover and call external tools, sources, services, and structured JSON interfaces. This comes from Anthropic. And tomorrow, same time, same room, Paul is going to be giving a whole talk on MCP. So I highly recommend going to this talk. So I'm not really going to go into it because he's going to do a whole deep dive there. But I briefly just want to show you what it looks like in my application, where I am calling the Zendesk MCP server to get context for my agent to know about the support tickets that I'm getting. But again, more on this tomorrow. You should definitely check that talk out. Now, diving into memory. We have both short and long-term memory, but let's look at long-term memory first. So agent memory is long-term memory here. It's just a database table with role, content, and run ID. And after every planner response, tool call, or user input, you just drop a row in agent memories. This creates a timeline of the agent's thoughts and context. And before asking the LLM planner for the next step, you can call .recall to fetch the recent context. This prevents forgetfulness too in long-running sessions. Next, we'll talk about state store. This is short-term memory. It's essentially the single source of truth for an agent's run or current working state. Think of it as the orchestration's layer memory. It's not long-term memory, not logs. It tracks everything the planner and the agent needs to know to continue execution. It has run metadata, current plan, tool outputs, error retry, gate decisions, things like that. This is important for resumability if something goes wrong, for concurrency, and also just knowing you're making the right choice, right? Hopefully. So here we have @run. @run is our state store. It is a JSON-B column. It holds all run-scoped working data. We have pointer and we have set pointer here to give you a clean way to store simple cursors, like which step you're on or the last tool used. And we also have statuses to know if the agent should keep processing, pause for human review, or stop. Then we have agent orchestration, which is a really big part of building agents, right? It's the logic that plans, executes, and supervises multi-step agentic work. It calls our tools or the LLM, it implements guardrails, it persists state, it can also do retries and rollbacks, it observes and audits. It's really the glue between the LLMs and the business outcomes. And here is the code for this. We're asking the planner to for the next action, in strict JSON, of course. We store the raw plan as a workflow step, and then we gate the plan and do a quick policy schema check, making sure, does the user have access to this? Do they have any more, calls left to the LLM, things like that. We act again using MCP as our tool, an MCP server, and persist that as a step and accumulate state there. We then merge the tool's JSON and result back into our run context JSON. So the next plan can see it. And then, if the planner returns finished, we lightly gate the final answer and return the run. So planning. Planning is really another essential step for building agents. It's the executive function of an agent. It turns a goal into a sequence of steps and verifiable actions. In modern agentic AI, we have 4 tactics usually that we implement for this. We have sub-goal composition, which splits a big goal into smaller steps, exactly as it sounds, and the planner proposes the next action. We also have reflection. It takes a look at the latest output and then decides how to improve or what to try next. We also have self-critique. It scores an immediate or final result against criteria and then revises it or escalates it. And then we have chain of thought, which is internal reasoning of literally what you're going to do next. Should you persist? Should you not? Different things like that. So those are the four different tactics that we have for planning. And here in our application, this is an example how the planner returns strict JSON, either use tool or finish. We then persist the decision, not the model's reasoning. And here I'm using the OJ gem, which is the optimized JSON gem. In case you were wondering what OJ is here, that's what I was using. And then the orchestrator uses it, right? Here it is, kind of deciding, do we use a tool, do we finish, based on the plan's action. All right, now we've talked about all the essential building blocks and kind of what that looks like in our support bot agent application. We're gonna talk about best practices when it comes to building these agents. And these are all based on things that we have learned on the agent team at GitHub, so I wanna share those with you. The first one is modular and maintainable. I feel like this is a given because other types of software should be like this, but I feel like it's even more important when building agents, to be honest. They're complex. They're tightly coupled, all of these building blocks, and you don't want to make one small change and everything breaks. Also, things are changing rapidly. Tooling, strategies, everything changes every few months. So we want to make sure that we can keep iterating constantly because it's essential, or else you're totally going to lose the game, right? Everyone's moving so fast. So it's really important that you make these modular and maintainable so you can continue to iterate and kind of keep up with the times, right? Also, gates. I've talked about this a little bit as we've gone through these building blocks. They're essential. A gate and a guardrail, whether it's policy checks, rate limit checks, or even just asking the human. For example, in the coding agent, it asks you if you want to keep the code that it has written. So you either can say keep or undo. So it's just really important that you're adding these gates. And here's an example in our application of what that looks like. And our common arg schema is a validation contract. I'm using dry schema, gem. It ensures any agent request to create a Zendesk ticket includes certain things that I need. Also, prompt changes. We keep prompt changes and guidance minimal. When I actually first went to make a prompt change in our runtime, I had this huge paragraph of text, and everyone laughed at me and was like, wait, no, you need like one sentence. A really harmless tweak can cause the planner to stop using tools it should, hallucinate new actions, or break JSON contracts. So it's really important that you keep these as minimal as possible to guide kind of the agent where you want it to go. Also, extensive testing. We do extensive testing with nightly evaluations that run every night. It's really important, and there's actually going to be another whole talk on this. This is tomorrow at 3:45. Andrew and Charlie from Shopify are going to be talking about LLM evaluations and reinforcement learning, so definitely recommend that you check that talk out as well. Test harnesses, these are really important. They allow us to lock in behavior, tweak prompts, and also drive down our number of tool calls. And observability. Everything the agent does needs to be tracked, inspected, and explainable. A lot of the building blocks we went into, like memory, are essential for observability and ensuring that the agent remains ethical and dependable. So here, just really quick, in the Copilot coding agent, you can click View Session once Copilot creates a PR for you, and you can see and track literally everything that it did and thought. And I really think this is important for accountability and things like that. So you may be wondering what the future of agents look like. We have a really good idea of where we are, what these look like now, but I really think that agents will continue to be more human-like. I don't know if anyone has heard of the word anthropomorphization. I can barely say it. But basically, it's the attribution of human traits, emotions, or intentions to non-human entities and how those apply to humans. So making things that are not human more human-like. And I think it will become more about how the agent feels to use. What is the personality of the agent? Building relationships with these agents as memory and things like that improve. They're really going to get to know you and how you write code and things that you value, and become more ethical, dependable, and aligned to a brand. And I think voice, tone, values, consistency, things like that will be just as important as what the agent is doing itself. Also, sub-agents are a big thing. We're working on this currently at GitHub on our coding agent. But basically, we're going to see hierarchies of sub-agents, kind of like SRP that we all know and love, Sandy Metz, where each agent has its own responsibility. So, for example, our support agent can look something like this, the architecture here, so you can see each has its own responsibility instead of just one big monolithic agent. So kind of breaking that up so each does its own thing. Also, workflow native. Right now, we build workflows around an LLM. Future systems will natively model workflows, branching, retries, checkpoints, and rollbacks. This is where agent orchestration will become central. It looks more like a chat loop. Instead of a chat loop, it's more like workflow engines with LLM steps inside. So I'm thinking maybe a blend of traditional orchestration tools like Airflow or Temporal, if you've ever used any of those, with LLM-aware adapters. So yes, agents and the future of agents are really exciting, but we really have to remember that agentic solutions are often an over-engineered solution. A lot of times I personally find myself working or wanting to reach for the shiny new toy, yes, but instead using that in a side project versus production might be better, building an agent that you need in your life and learning all of these concepts on your own. So it's really about choosing the right tool that you need for your problem at hand. And then, really quick, we're going to talk about kind of ethical considerations of agents. Transparency. We've talked a lot about transparency, observability, different things like that we really need to be transparent with what our agents are doing and make sure the user is aware too, and include them as you develop. You can also, steer Copilot and different things like that. I think that's important. Also, biased. We really need to be questioning the algorithms, the LLMs that we're using. Are they biased LLMs? I'm not going to name names on, the LLMs that I think have issues, but I think we need to be aware of those. And also dog fooding. So we do a ton of dog fooding on our team to use it because we want to make sure that, our agent is doing what we expect it to do and is not biased. Safeguards. Gates and policy checks, it's really easy to build an agent without these, but I really think these are essential for ensuring that they are on track. Also, security and retention policies, make sure you have those set on your team if you are building an agent. Easily visible to developers, things like that. And like I mentioned, audits, dog fooding is great. Make sure that you are doing all these things on a regular basis. And as far as Ruby and Rails tooling, we've been a little bit slower to adopt. A lot of the major SDKs and tooling have been in TypeScript and Go and other languages, and we need to ensure that Rails remains relevant. So I would love to talk with you all on how we do that and how we continue to be a major player and keep up in this space. Also, we want societal impact to be positive and not negative. I've heard a lot of talk of people saying that they want to replace developers, but I think we should really focus on augmentation and accelerating versus replacing. We shouldn't be using that word. And it's a fundamental evolution on how we build software systems. We can move beyond traditional programming paradigms towards systems that reason, learn, and adapt to changing conditions. We now have powerful capabilities that can dramatically change our work. And for me, that's really important because I can focus on the thing that matters. I can spend more time with my kids. But how can we build agents for good? How can we make these a powerful thing in our society that are bringing positive impact and not negative impact? How can agents make our world better? But also, really important, how can it make your world better? Thank you.